I was pretty excited to go to Adrian's lab at University of Montreal. He has a full-out X-ray fluorescence instrument. Adrian, this is your lab.
It is.
Oh, I'm a little jealous.
This is a Cadillac of XRFs.
Aha. I see you got a sample. Are you running some stuff right now?
Well, this is from a quarry
Okay.
that's right near the university here, pre-contact quarry. We actually find flakes of this at Île Saint Bernard.
Okay.
So what we're going to try and do is analyze the geochemistry of this hornfels from this quarry, just to make sure and prove that it is actually what we find at Île Saint Bernard.
Right. Can you tell me a little more about the capabilities of your instrument?
So this is really a research grade X-ray fluorescence spectrometer. So it's used to try and measure some elements that are very hard to measure, like what we call rare earths and lanthanines. A lot of times it's those unusual elements that'll help you really tell that it's from this quarry or this, mountain, as opposed to another quarry, for example.
How do you load this thing up?
So I'm going to take the geological sample that we took from the quarry, and I just literally put it in the sample holder, and then I basically open the door here to the XRF, and then we put it right here. And what happens is that I close it because there are X-rays, so we have to be careful. I have to program the sample and tell it what to do. Do I want it to analyze it for 10 minutes, an hour? What kind of elements am I interested in? And then what'll happen is it'll take the sample, put it in the actual chamber where it's really exposed to X-rays, very strong X-rays.
So, an hour. How long do you run your samples for?
Well, when we're trying to do really the research type stuff to really tease out the differences, we actually run every sample 3 hours.
3 hours?
Yeah. The reason we run it longer is we try different energies, different targets. It's a way of using kind of like different kinds of X-rays to find different elements within the rock.
Okay. Is the instrument done now? Can we look at a spectrum?
Yeah, we can look at a spectrum. I'll try and zoom in here. What we want to do is figure out what each one of these peaks represents. Now, we're very lucky. We have new applications now that make it a lot easier than it used to be. The application is able to immediately tell us that this is most likely, down here in the left, the iron K alpha peak.
Yeah, okay. Fantastic. Well, this is a pretty high powered research instrument, and it's a little different from mine, but someday I'd like to have something like this in my lab. So.
Well, I think like always in science, the best thing is to have different instruments for different applications.
Yes.
The handheld portable instrument is fantastic. I think it's revolutionary for archaeologists. What we've been trying to do lately is use this instrument to analyze the same kind of samples, let's say the geological samples that we can take out of a country, create a kind of a reference database, and then use the portable instrument
to do some checking,
to analyze those same samples. And then when we go to, let's say, Guatemala or wherever we are, it actually allows us to even improve the way we use the handheld instrument.
Indeed.
Which is kind of great. So the two are complementary. One allows you, of course, to go anywhere and do hundreds of samples in a day. This, of course, is not that kind of throughput, but it produces a different kind of data. But the nice thing is that they're comparable. So.
Sure. Well, maybe down the road we can collaborate
Absolutely.
on some of those things.
That would be fun.
Okay. Thanks, Adrian.
You're welcome.